Welcome to the 4th annual GradSlam competition. My name is Carl. On behalf of the Graduate and Postdoctoral Programs Office, we'd like to welcome you all here this evening. Thank you for coming to cheer on, whether it's your colleagues, your students, or maybe you're just here to actually learn something. That would be great as well. But what we have tonight is 8 speakers who will be up here. They have been preparing over the last 5 weeks for you for this evening. They've had a number of different sessions teaching them how to present their research to everyone, to make sure that everyone can understand the great work that they are doing. They've had one-on-one sessions. We originally had 30 students and postdocs who were engaged in these sessions. We had 21 semifinalists, and tonight we're down to our 8 finalists. And I know for me, this is one of my favorite nights of the year. I spend a lot of time on the road bragging about how great NYU Abu Dhabi is. This gives me about a year's worth of things to brag about. So thank you all for everything that you've presented, and we're looking forward to hearing everything tonight. So what is this competition? Like, what are we doing? Like, how are these students and postdocs being judged tonight? Well, we have a number of different criteria that we have, and this is all, again, in a 3-minute presentation. And so students are being judged on the clarity of their presentation. I'm gonna make sure I get all of these. The organization, the delivery, their visuals, whether it's appropriate kind of for a general audience like we have here, their significance, why is their research important, and then their engagement. Did it get you to really care about what it is that we're talking about? And so to help us figure out who has done the best and who is going to earn one of the 3 great prizes that we have today. We have a $1,000 People's Choice Prize, a $2,000 second place prize, and a $3,000 first place prize. And so to help us with that, as we use this clicker correctly, we have our panel of esteemed judges here, and I will introduce them all very, very quickly. So coming all the way from the city that doesn't sleep, we have our Vice Provost and Academic Program and Review, our Vice Provost of Academic Program Review and Doctoral Affairs from the New York campus, Diana Arpino. Thank you, Diana, for being here. Up next, NYU Abu Dhabi's own Assistant Vice Chancellor of Global Research Programs, Yvette Lane Newton. Thank you. Representing our sponsor that we have here today, Sami El-Fingari, Chairman for Pharmag. Thank you. And from the Ministry of Higher Education and Scientific Research, Farida Alian. Thank you. So I just mentioned that we are very, very excited and very, very lucky to have a fantastic sponsor this year for GradSlam with our partners at Pharmag. And I know, one of the things that we promote here at NYU Abu Dhabi is innovation. You're going to hear about a lot of this type of innovation in STEM areas from our students this evening. And so to share a brief word kind of about how we both are supporting this type of work, I'd like to introduce Ashraf Malik, who is a Vice Chairman of Pharmag. Please come on up.
Thank you, Carl. Can you hear me? All right, so just disclaimer, my name is Ashraf Malik, so it's double L, 1A, so it will be different here. Okay, so ladies and gentlemen, esteemed partners, distinguished faculty members, and dear students, good afternoon and welcome to GradSlam 2025. I'd like to start with a small introduction to Pharmag. Pharmag is an association that brings together more than 25 of the world's leading research-based pharmaceutical companies in the UAE. For the past 20 years, Pharmag has been formed. And over the past 20 years, we've been at the forefront of advancing pharmaceutical research, innovation, and knowledge sharing across the UAE and the Gulf countries. Our mission has been always to support researchers, scientists, and innovators in creating impactful solutions for the society. And that's why we are pleased to be at New York University, Abu Dhabi, surrounded by so many talented individuals who are so ambitious and ready to change the world. At Pharmag, we firmly believe that innovation begins with people, with researchers and thinkers like you, and like the 8 finalists that we will have today, who are driven by asking the right questions, by challenging what's possible, and transforming bold ideas into real solutions. This year's collaboration holds special meaning for us as Pharmag celebrates its 20th anniversary. So our support for GradSlam reflects our enduring commitment to advancing innovation, building cross-sector knowledge, partnership, and supporting the next generation of STEM scientists and researchers. This is very much aligned to the UAE's vision of becoming a global hub for innovation and excellence. Today's event is also a powerful reminder of what can be achieved when the private sector, academia, and the wider community come together. When we unite knowledge, creativity, and purpose, we create the conditions for groundbreaking discoveries and lasting impact. However, we must also remember that science is not just about discovery. It's also about the 3 C's. The 3 C's are communication, collaboration, and connection. Being able to share your research clearly and passionately is what bridges ideas with actions and what transforms innovation into progress. I'm sure that all of you who are going to present today have spent years exploring complex problems and imagining new answers. Today is your moment. It's your moment to share those stories, to inspire others with your vision, and to show the difference that your work can make and bring to us. To our finalists, enjoy the moment, support one another, and let your passion truly shine through. On behalf of everyone at Pharmag, I wish you all the very best of luck. We cannot wait to be inspired by you, and I look forward to congratulating our winners and sharing their well-deserved awards and the prizes. Thank you very much.
Thanks, Ashra. Thank you, Ashra. I know tonight will be a journey for me to get everyone's names correctly, and I've already failed once. So let's see if I can do better throughout the rest of the evening. But we appreciate just having a great collaborator for this event, and to encourage our students and our postdocs about how their innovation can be shared with the world and to give them the skills to do so. And without further ado, we're going to start by asking you all to please turn off your mobile phones. I don't know if you've ever been on a stage like this. It can be very distracting if all of a sudden a phone goes off in the middle of your presentation. So we ask you right now to do that and to please remain seated during the presentations. Again, the presentations are only about 3 minutes long, maybe slightly shorter. So hopefully you can wait until after every student or postdoc gives their presentation before, if you do have to leave, you'll be welcome to do so while we're having some chats up here. There. And so we're going to start right away with the presentations. And again, make sure that you're paying attention to all the presenters tonight, because at the end, we will have a QR code that is going to go up onto the screen here that will allow you to vote for your choice of what you thought was the best presentation this evening. So while we have our judges, we also have you as the audience that will be helping award some of the prizes that we have to give away tonight. These are our presenters. We have 8 that we'll be going through for this evening. We're going to go through in alphabetical by first name order. So starting up first with Powering Up the Immune Army, a smarter way to treat cancer. We have Brian Chesney-Corti. Give a round of applause, everyone.
Each and every person sitting here in this room today starts life in the womb as a cell. This single cell divides again and again and again, forming the entire body that is sitting here today. In fact, as you're sitting here in this room, the cells in your body are continuously dividing. Now, the process by which cells divide is guided by rules. Cells have rules on when to divide, how to divide, and how much space they can take. Now, a lot of the times you have good cells that do the right thing, but sometimes you also have these rogue cells that decide to do whatever they want. They divide however much they want, they take up however much space they want to take, and they make you sick. This is cancer. Cancer is the second most deadliest disease, accounting for over 9 million deaths every year. Now, currently, our most popular form of treatment for cancer is chemotherapy. Chemotherapy's strategy is to go hard at cancer. Now, basically, it sprays a bunch of chemicals around the body in hopes that it can eliminate the cancer cells. The problem with this is that it's not specific, because while you can eliminate some cancer cells, you also end up damaging good cells. They're good guys. They haven't done anything wrong. Now, it turns out our body actually has an army that can fight cancer. It has soldiers called T cells that can actually specifically identify these rogue cells and eliminate them. Its work depends on information it gets from another immune cell type called dendritic cells. These are the spies of the body. They're everywhere in the body. They have all the information on what goes on in the body. They're gossips, basically. They have all the tea. Now, once they realize that they're rogue cells, they can gather this information and they can go tell the soldiers that, hey, there's these guys that you need to go take out. And then the soldiers can go take them out. Now, I'm sure you're wondering, if we have all this, why does cancer even develop in the first place? The thing is, cancer is smart. Cancer makes up a lot of ways that can be able to make things hard for the army. In my work, we've shown that it actually restructures the environment of cancer, and this restructuring actually makes the spies exhausted. They're so tired, they're not able to gather the information they need to gather, and they're not able to go tell the soldiers that, hey, you need to go eliminate these guys. Now, to solve this problem, my work aims to provide these spies with energy-boosting molecules. We're packaging these energy-boosting molecules that cells usually use to generate energy, and we're delivering them directly to the spies. This way, we're able to energize them such that they have enough strength to be able to collect information and to be able to go instruct the soldiers to eliminate cancer. Because if we want to eliminate cancer, it's not about fighting harder, we need to fight smarter. Thank you.
Thank you, Brian. So Brian, I'll have you stay up here for a second because you get to answer a few questions. So why don't you tell us a little bit more about yourself, your background and how you got here.
So I grew up in Ghana. That's where I went to school all my life, high school. And then after high school, I wanted to go to university outside. So I applied to a bunch of US universities, including NYU. So I actually did my undergrad here. And after undergrad, I also looked into applying to PhD programs because I had a lot of research experience while I was here. And I knew I wanted to be in research and contribute to research. So I actually got into a good number of programs, but eventually I decided to actually stay here because the environment here, standard of living in the UAE, which I think was like ideal.
We got you. Yeah. We got you. We roped you in to stay. So what got you interested in working on this type of research? Like why did this catch your eye?
My research interests have actually been a long road. I started from before, like around high school, being interested in mechatronics. And I remember watching videos of this guy called Huge Hair. And he's basically a double amputee that has these prosthetic limbs that are they're almost human-like. So I started getting interested in the idea of being able to give people with disabilities or people with parts of the body that are not functioning properly, basically being able to replace them. And then eventually in college, I heard about tissue engineering. I was like, oh, that's even better. So basically that and a long road led me to tissue engineering within the immunoengineering field and trying to basically engineer immune cells in the tissue as well.
Fantastic. Thank you for sharing that. I think we are good here, so we'll ask you more questions later. But thanks for your presentation. Right. Great job. All right, our second presenter for this evening, we have DNA on the menu, serving up genetic scores to save a heart. Please welcome Iman Morjan.
Hello. You might be wondering, what are these heart emojis doing here? Is it a talk about social media? Or am I willing to ask you about your current relationship situation? Well, I hope it's great, but I'm here today to ask about real hearts, particularly cardiovascular diseases. According to the World Health Organization, CVDs claim almost 18 million lives each year. Just imagine. This is equivalent to all the population of the UAE, Qatar, and Oman combined, gone in a single year. CVDs are caused by genetic and environmental risk factors. My focus is to use the part you cannot change, your genome. Think of your genome like a biryani. Every biryani has rice, spices, and some protein, but no two taste the same, right? Similarly, we all share 99.9% of our genomes. And that tiny difference is what makes each of us unique. You might be wondering, how come that this small percentage responsible of such huge diversity? Well, because our genome is made of 3 billion chemical units, and you will need all these books of thousands of pages to print one human genome. So my research focuses on turning these small differences into individual predictive scores called polygenic risk scores. Think of these like a genetic calculator that adds up small effects of DNA changes to estimate the individual risk of developing CVDs. So it was estimated that 7% of CVDs can be prevented just by incorporating PRS to conventional risk factors. That also will help people that already have CVDs to get treatments that are tailored specifically to them. But there is a catch. Imagine if we take these effects from well-studied populations and try to apply these to Emiratis. It's like making biryani using sushi rice. Sticky, right? So this is why national initiatives like the Emirati Genome and our study, the UAE Healthy Future Study, are crucial for Emiratis and for the neighboring populations. By learning from our genomes today, my research will help ensure that your health and your smile are taken care of proactively. Thank you.
Thank you, Aman. So, Aman, why don't you tell us a little bit more about yourself? Yeah.
So I'm from the lovely country of Morocco. I studied there, and then grad school was between France, Aix-Marseille University, and Hassan II University in my hometown. And then I had the chance during my PhD to meet my one and only mentor. I know he doesn't like praising, but he's really special. Professor Idagdur Youssef, and he's also the director of the Public Health Research Center. So I met him while giving a talk in Dubai, and it started there. He was so generous to give me the chance to attend his online lab meetings back then during Corona. And then there was a position that was open in his lab, and I was the lucky one.
And here you are.
Yeah.
So I have to ask, of all the heart emojis, which one's the best one?
Sorry?
Of all the heart emojis, which one's the best? You had so many that were on there. Which one do you use the most?
I'm a girl.
And so how did you get started then, interested in kind of CVD and like wanting to study that area?
So what I'm sure of is that I wanted to study something related to human body. I didn't make it to medical school, so I shifted toward biology, and then I did my master's on human pathology in the medical school in France. And then during my PhD, I focused on the genetic part of cardiovascular diseases and metabolic diseases in general. And this is like the continuum of my PhD.
Great, great. Well, thank you. Great job, and thanks. All right. All right, up next, our third presenter. We have From Waste to Healing, Giving New Life Through Biomaterials. Please welcome Jawahar Al-Yamahi.
I'd like to make a little confession. Ladies and gentlemen, I ate last week, and I'm sure you all did too. Guess what, people? We together generated more than 500 kilograms of food waste just last week. And in the UAE alone, we generate more than 3.3 million tons of food waste per year. Have you ever wondered what happens to all that food waste that we generate? Well, most of it ends up in landfills, forgotten. But what if I tell you that this waste could one day heal broken bones, repair damaged tissues, or even save lives. Hold on to this. Millions of people suffer from major injuries. And to help them recover, doctors often rely on implants made of plastics or metals. However, our bodies are not made of plastics or metals. And these implants could cause rejection, inflammation, or even fail over time. So what is the alternative solution? To find a solution, I turned to nature for inspiration and to my ancestors who used natural remedies to cure many diseases. In my lab, I transform biological waste into a biomaterial that can help human body regenerate itself. From the date waste, I extract strong, flexible nanofibers, and from the fish skin, I extract collagen, which is simply the protein that gives our tissue their strength and structure. Now imagine with me combining both waste from the desert and the sea to produce a soft, gel-like material that mimics the environment of our own bodies. Cells love it. They start attaching, growing, and even behaving like real tissues. Now, what is interesting part about this material is their ability to accelerate healing by up to 75% as compared to the traditional ones. They can also be 3D printed into various customized structures, like a smart patch for wound healing, or a scaffold for bone regeneration, or even an engineered contact lens for color blindness. So in other words, these biomaterials could enable a personalized, patient-specific treatments. However, the beauty of this work goes beyond medicine. It's about healing both our planet and people by giving waste a second life and our humanity a new path towards recovery. So yes, you all get to eat, and I'll take care of your waste and turn it into a cure. Thank you.
I'll take the clicker for there we go. Joanna, thank you very much. Can you tell us a little bit more about yourself?
So I'm Jawahar Al-Yamahi, an Emirati postdoc. Just to walk you through my academic journey, I did my bachelor in oil and gas related topics. Then I did my master's in research related to more like plant biology. And then I moved during my PhD doing research on food technology. And now I'm doing research on tissue engineering and 3D bioprinting.
And that's quite a journey that you've taken. So, well, can you tell us, was there something you mentioned about how you were inspired by like your ancestors, like ancient practice? Was there something from your own life or experience that kind of gave you some of these ideas?
A great question. So I had a few images in my previous slides. So there was a fish skin on the top of open wound. So basically, our ancestors used these fish skin to cure severe burns. So that was the first inspiration, and the other one was basically in the region. Before we used date paste to basically fasten the healing of the bone fracture. So that was the two inspiration that enabled my use.
And I thought for me, dates just cure my afternoon snacking that I need. So that's great. Well, thank you again for sharing, and we'll I'm sure have many questions for you later too. Take care. All right, up next, we have Buried Potential, the underground climate solution. Please welcome Metha Alayi.
Right now, there's something surrounding us that shouldn't be there. We can't see it, smell it, or touch it. Yet everyone is affected by its presence. It's heating our planet, drying lands, intensifying storms and wildfires, even melting glaciers. So, what is this thing that's causing the whole world to suffer? Carbon dioxide. For years, we've taken oil and gas from the ground and burned them. They powered our cities, grew our economies, but they also release far more CO2 than our planet can handle. Now, we're racing to cut our emissions. You've heard of the solutions: renewable energies, electric cars, and yes, they matter, but that's only half of the battle. because there's still tons of CO2 accumulated in our atmosphere, and it's not going anywhere. So think with me, a crazy idea. What if we captured this CO2 and buried it underground to the very same rocks that once held it safely for millions of years? Crazy, right? Turns out it's already happening. CO2 is being stored safely and securely around the world. However, to meet climate goals, we need to scale it up by at least 20 times. Here in the Gulf, we have enormous potential. Hundreds of former oil and gas fields no longer in production. But potential alone isn't enough. Our underground environment is far more demanding and challenging. The rocks are hotter, saltier, and older. So we can't rely on the same techniques used elsewhere. And that's the current problem we are facing here in the Gulf. And that's where my work comes in. I'm developing a computational model that predicts how CO2 will behave underground, how it moves, reacts, and transforms over time. Under our unique conditions, I can test various scenarios with different injection rates, pressures, and temperatures. That will help us make critical decisions like where to inject and how much to inject. With models like mine, we can turn potential into practice. We can turn an old story of extraction into a new story of restoration, because the solution to this global problem is right beneath our feet. Thank you very much.
Thank you, Maitha.
Thank you.
So why don't you tell us a little bit more about yourself?
So I'm also an Emirati postdoc here at NYU. I did my bachelor's in the United Kingdom in University of Bristol. I was an undergrad in mechanical engineering. And then for my master's and PhD, I continued with nuclear energy. And now I'm into computational model, and you might be wondering, how did I get from nuclear into computational modeling for carbon storage? Well, they all target the same problem. With nuclear, it was reducing the amount of CO2 we produce, but then I came to think there's still tons of CO2 accumulated in an atmosphere and not going anywhere. So we also need to tackle that issue, and that's how I came here today.
And how is, what are the plans for capturing, CO2? Is there like a big net, a dinosaur that's going to chop? Like what do we use?
There's special machines that filter the CO2 from the air, compress it, and then we can inject it underground.
And you said that a lot of this is tied to, because here in like the Gulf region, there's a lot of...
So the main difference is that all the storage facilities elsewhere, their rocks are very, very different. So we have another set of factors to take into account.
Okay, great. Well, thanks for sharing, and
Thank you so
we'll hear more
much.
from you later, too.
Thank you so much.
Thank you. All right, up next, from hallucination to truth, fixing AI's mistakes by filling the missing links. Please welcome Ola El-Khatib.
August 22nd, 2 a.m. My baby woke up burning with a 40-degree fever. I gave him Panadol, Advil, nothing worked. I remembered the doctor once mentioning Voltaren for emergencies, but I wasn't sure it was safe. Pharmacies closed, the doctor was not reachable, so like millions of people today, I desperately turned to ChatGPT. It confidently told me that Voltaren should never be used with children under 14. So I trusted it and waited. My son spent the night restless, shivering, and burning with high fever. The next morning, the doctor was shocked. He told me Voltaren can be safely given to toddlers in urgent cases, and that the night I waited could have ended in a seizure. That night, I trusted an AI for emergency, and it let me down. What happened to me could happen to anyone, and in fact, it already is. Almost 1 in 6 adults worldwide turn to AI chatbots for medical advice. For many, especially where healthcare is expensive or out of reach, AI feels like the only option left. But here's the problem. AI hallucinates. Up to 20% of its confident answers are wrong. And in high-risk domains, this could end a life, break a mind, ruin a future, or even distort justice. Imagine an AI that wants to give a medical advice. It's like a genius who has read everything on the internet, but never really went to medical school. You know, the kind of person who would confidently convince you to use bleach to cure your sore throat? He would nearly kill you and then get away with it. Well, technically, I did warn you, I'm not a real doctor. And here's where my research comes in. I work on making AI factual and trustworthy. How? By equipping this overconfident genius with a source of verified information, or what we call knowledge graphs. Think of it like a huge network of interconnected information. However, a challenge in these graphs is that they are incomplete with many missing links. And maybe that missing link is the one that you desperately need at 3 a.m., just like the link between Voltaire and an urgent toddler care. So, how do we fix it? By projecting the graph into a space where related facts are brought as close to each other, even if the link is missing. Then we can fill in the gaps, complete the graph, and provide the model with more information to rely on. In fact, teaching AI to reason over large yet incomplete knowledge graphs can reduce hallucinations by up to 70%, making AI much safer. This is why this work matters, because when the world starts listening to AI, we better make sure it speaks with knowledge, not only confidence. Thank you.
Thank you, Ola. So Ola, tell us a little bit about yourself.
Okay, so I'm Ola. I'm from Lebanon. I did my undergrad in computer engineering at American University of Beirut, and I did my master's in mathematics. So I shifted from engineering to mathematics. Then I shifted to industry for 5 years. Then I came back to university for my PhD in computer science.
That's great. And so during this time, I mean, you've kind of started your PhD maybe as the AI boom was really happening. So like, what are like kind of the major changes you've seen, as a student as you've been approaching this?
As a student, I can divide my research journey into before ChatGPT, after ChatGPT. Yeah, so before, like I was working on things, and then everything changed after that. Because so now everything is working on making AI safer. How can we live with AI? Because it's there and we have to live with it.
So that's why all the PhDs in computer science are asking for 5-year extensions now. Yeah, it's like, oh, we have to start over. We have to keep going forever. Well, thank you for sharing. We'll hear more later from what you have too. Thanks, Ola. All right. Up next, here we go. We have discovery cancer drugs using cell painting. Please welcome Restaurant Luis.
Hello, everyone. Before starting, I want to ask, how many of you have seen people painting house? Okay, 21 people. Now, keep your hand up if you think that painting could save people from the cancer. Nobody. Ladies and gentlemen, my name is Restuan. I'm a painter, but I do not painting house. I'm painting cancer cells, and I do it to save people's life. The reason my work is matter is because it is urgent. During this 3 minutes presentation, cancer will kill people, at least approximately 60 people. That's why my project focusing on to find a cure, and I do it by painting. Think about it like this house. Before painting, it's hard to see the detail. I do the same thing in the lab. These are cancer cells before painting. Everything is gray, it's hard to read. Then I developed a formula magic dyes. Once I add, boom, the cell is light up. Now we can start to see the nucleus of the cells, the walls of the cells. But the big question is, Restuan, how do you find drug cancer using this method? It is simple, visual test. So you take cancer cells, and then you add one by one potential drug, and then you paint them. You do this over and over until you find which one drug that can change the painting from the cancer look like to the healthy one. Simple. But here the second problem. I don't have one drug to test. I have 50,000 drugs to test. If I do by myself, it will take 3 years. How many people will die? Too slow. Or I need to clone myself 160 times for help, which is impossible. To tackle this problem, I replace my strong arm with this robotic here, so I can program the arm to prepare the sample, mixing the cells, test one by one drug, and then paint them, and then after that, taking the picture automatically. And also, I utilize AI to select which one drug over this 50,000 drug that change the painting. And for the record, traditional way to find a drug for cancer, it takes up to 5 years. But here, in NYU Abu Dhabi, this guy and I can discover a new right drug for new right cancer only in 5 days. So 1 week, halas. Ladies and gentlemen, my name is Restuam. I'm a proud painter, and I'm using my paintbrush to combat cancer. Thank you.
Yeah, take that. Restaurant, thank you very much for sharing. Tell us a little bit more about yourself. How'd you come to NYU Abu Dhabi?
Yes, so basically I'm from Indonesia. And before coming here, I do my PhD in industry. So it's a lead discovery company, biotech company in Germany. And I use exactly this robotic platform for screening a new molecule against different cancers. And then after that, my life, like I discussed with my wife, so what about it come back to Indonesia? And then at the end, in the meantime, our discussion, we tried to find the middle country, so Middle East. Across the Gulf, the only one has this platform only in NYU Abu Dhabi. So yeah, I tested, I joined, and I reached the supervisor, so yeah.
Well, we're very lucky to have you here working on this. So as a painter, do you consider yourself more of like a Picasso, a Van Gogh? Like what?
It depends on the type of the cancer. So it depends whatever you painted, because the morphology is different, basically.
Yes, so there's some, impressionism in there, so they, and then what got you kind of first interested, you said you started kind of in industry and moving to paint. How did you see this idea of applying kind of paints to cancer cells?
Yeah, basically to discover drug cancer, there are different methods. So for instance, phenotypic screening, where you can just screen or test one by one compound drugs and then measure the bioavailability of the cancer cells. But here it's more robust, so you have every single, let's say, parameter. So you see the nucleus. What about if the drug cancer only the nucleus or the cytoplasm area of the cell?
Yes, got it. Fascinating. Well, thank you again for sharing. All right, next up, we have Rewriting the Code of Aging, the Future of Human Health Span. Please welcome Yusra Ajwal.
Let me start with the question nobody really likes to answer. How old are you? Don't worry. We all know that number can be completely made up, right? The real question here is how old are you from the inside? Because inside every one of us, there is another kind of clock, one that doesn't count birthdays, but how our body feels those birthdays. That's your biological age. And what controls that clock is something called the epigenetic code. Now, to understand what's that code, imagine your DNA as a library of life, holding thousands of volumes that record all functions your cells can do. The epigenetic code is the librarian who decides which books to open and which to keep closed. When we are young, the librarian is sharp, always picking the right book at the right moment for repair, renewal, and balance. But with time, shelves get messy. The librarian loses track. Books on stress and decline are opened too often, while those on regeneration stay forgotten. That's how aging begins. Not because the library is empty, but because the librarian forgets how to explore it. Now here's the real problem. Aging is not just time showing on our faces, right? It is the strongest risk factor of almost all major diseases: heart disease, cancer, diabetes, and Alzheimer's. And as the population, the global population ages, it's becoming one of the biggest health and economic challenges in the world. So by targeting unhealthy aging, we could target all these diseases at once. That's where my research comes in. I study how the epigenetic code shapes the way we age. To do so, I focused on the liver, one of our most fascinating organs. It performs over 500 vital functions, and it is the only organ capable of regeneration. And that unique ability declines with age. For my project, I changed some part of the liver's epigenetic code in mice. And what we found was incredible. The old livers in my modified mice start regenerating like young ones. But the change didn't stop there. The mice themselves stayed young and active with less gray hair, and not a hint of that middle-aged belly. Basically, in human years, my 70 years old mice were biologically 30 years. Amazing, right? My research is the proof that aging is not just a countdown, it's a code. And codes can be rewritten. And one day this can be applied to human. With just a pill, we can reprogram our epigenetic code to help our cells regain their own youth. Because you know, longevity is not about living forever. It's about staying healthy for longer. And this could be possible simply by reminding our bodies to read the right books at the right moment. Thank you.
Thank you. So I guess the first question has to be, how old are you? No.
That's a good question.
But why don't you tell us a little bit more about yourself?
Yeah, so I'm Moroccan, born and raised in Belgium. I did my bachelor in biomedical sciences. Then I went for a master in molecular biology. And during my master's, I was interested in inflammatory bowel diseases. So I went to UK in the University College of London, where I deepened my knowledge in immunology. Then I came back to Belgium to do my PhD in immunology. Then during my last year of PhD, the COVID happened, so we had to reorganize ourselves. So I went to Luxembourg to do omics data, because that's where we can do, like we cannot go to the lab anymore. So I did a visiting researcher position there to learn all about multi-omics. And so then after that, I came here for a postdoc to work on aging and all of that.
So, I mean, it seems like you've been a truly global student
Yes.
in all the studies that you've had. And so tell us about like your time here at NYU Abu Dhabi. Like, do you see, is there things that you've taken from your kind of global experiences that you think have helped you, in the labs here and working?
Yeah, it really helped me because I could combine my technical skills with the omic skills as well. And NYU Abu Dhabi is really a hub for very great research. We have all these people that are like the cores are amazing here, so we could do very good research. So I think this helps a lot.
Yes, well, I think you have a lot of people here that are probably ready to be the first ones for clinical trials.
Stay tuned, because there is something big coming. I'm telling you, like the mice, they don't age.
Oh.
Like really, it's amazing.
Well,
And
it's our secret for now, everyone.
It's a secret. It's under patent, so it's like.
Great. Well, thank you for sharing. Right, thanks.
you.
Great job. All right, and we have our final presenter for this evening with the pill that sticks, fighting cancer with Velcro. Please welcome Yusheng Jason Zhang.
What would happen if you ate 5 cheeseburgers a day for 10 years straight? Well, chances of you getting cancer, especially in the intestine, will greatly increase. But I love cheeseburgers! Well, lucky for us, there's a fancy gadget widely used. It's called the pill cam. You take it like a pill, it goes down into your stomach and intestines. It looks around for signs of diseases ranging from small infections all the way to cancer. And based on that, it tells you if there's something you have to look out for or if you're good to keep having cheeseburgers. Sweet. But wait, what if I have to go to the bathroom? Am I gonna lose this? Like, into the toilet? Ew. Yes, on average, this only stays in your body for 9 hours. But What if the cancer kicks in at 9 hours and 1 second? And before you say anything, no, we are not reusing this from the toilet. Here's the thing. Someone with intestinal cancer has a survival rate of over 90% if it was detected at an early stage. This means that one of the best ways to fight cancer is actually simply by catching it early. It's a shame because we have such a powerful tool here. All we have to do is actually take full advantage of it so it's watching out for us way beyond the 9 hours. But how? To answer that, we look to the intestine itself. A few things stood out. One, it contracts and creates an inward pressure. We want to use this pressure to push our device towards somewhere secure. But where? You see those little pillars? Those are called the villi. They're hair-like objects that absorb nutrients. And doesn't this look like one side of a Velcro tape? Because that's what we thought, which is why we turned the surface of our device into the other side. This Velcro-like adhesion could keep the device in the intestine for over 7 days, allowing it to develop a comprehensive picture of intestinal health and predict cancer risk even after the device exits. Still, cancer isn't just going to go away because we found it, but in the future, if our device is also equipped with drug delivery and surgical capabilities, not only can it detect the issue, it could also stay and help us get rid of it. This is how we fight cancer with Velcro, and I cannot wait to share more of our findings with all of you in the near future. Thank you.
Take that for me. Thank you, Jason. So Jason, tell us a little bit more about yourself.
Oh, Carl, it says here that I'm a mechanical engineer, but I'm working on the intestine. And what's interesting is that before I came to NYU, I actually didn't know where the intestine was. I just called it the lower stomach. And so it's a huge learning process for me. But I was actually inspired to join my current research group because I myself have a lot of issues in my stomach. And I was introduced to this wonderful, wonderful tool here. And I was like, I needed that. And it would be so crazy if I could be a person that's also working on it and making it better. So here I am.
How many cheeseburgers a week do you eat?
I just had 3 before this event, about to do a couple more after.
Yeah. Hey, if you can't test on yourself, who can you test on?
Exactly.
Right?
I'm sacrificing myself for science.
So I know you did GradSlam last year as well. What have you learned in the year as you're preparing for another run here at the GradSlam crown?
Well, I like to think that every year is a fresh start, and I'm actually very, very much inspired by every single person here. And wow, I mean, their presentations are so good. It's really cool. And the thing is, during our research journeys, PhD, there's a lot of challenges, and sometimes I hate what I do. And I think, but here's the thing. This is one of those things that really reminds me of why I'm doing this, and that's because I love it. And, yeah.
And did you get to use these skills like this past year, between these sessions? Like how did, kind of going through the preparations for something like this help you out as a student or as a researcher?
Absolutely. So I think one of the key points here is that conveying what I do to a broad but intelligent audience. And a lot of times when you go to conferences or when you sort of tell people about what you do, even if it is like a group of experts, our fields are so niche sometimes that there's still terms or concepts that the other person might not necessarily understand. So it's actually a really good and interesting exercise to zoom out, step back, and think about it from, I guess, an outsider's perspective, and then look at how another person that knows nothing about what you do would come to interpret and understand your work. So.
Yes. Well, as somebody who has to regularly pretend to be a chemist, an engineer, a social scientist, all of these things when I'm talking to PhD students, I appreciate the kind of work that you're doing. And when you can explain this kind of stuff in ways that it's easy to understand, I think it helps everyone kind of get on board with the research that you're doing. So congratulations. Thank you again.
Thank you very much.
Everyone, round of applause. Jason. Now, while our judges, we kind of do our final tabulations of the scores. The first thing that we're going to do is point up to the screen here, where we will be having the QR code for the People's Choice for today. So you can finally get out your phones. Yeah. Put those on here. Up. It's coming. It's not me. Up. Ah, there we go. We've got that there. So yes, scan the QR code. Again, we have all of our presenters on the screen here, just in case you're remembering names or remembering what the presentation was. So have a vote on those right now. And then while you're starting to vote, I'm going to invite all of our presenters to come onto the stage as well as we dismiss our judges out stage right, I believe it is, to have their last sort of conversations about this. So yes, judges, please exit. Speakers, as soon as the judges come by, please come on stage. All right, speakers, and let's give another round of applause for our 8 fantastic speakers this evening. And then I'm going to grab, Jason, would you mind grabbing the microphone that's over there? And then, Toika, I believe we have one more mic right there. All right. So this is your chance. If you saw something interesting, heard something interesting, we're inviting you all to ask questions to our speakers this evening. Ask them things you want to know about this. I encourage you all to ask them questions, because if I start asking questions, it's going to be about their favorite music, TikTok videos, things like that. So let's learn a few more things about what we have there. And so if you have a question, please raise your hand. Toika will come around with the mic to ask a question. Ross is over there with the mic as well on that side. So any questions? First question. Oh, everyone's so shy. Oh, I see one. Is that one in the back? Waving? Yes? Yes, in the back, Toika.
Hi, I have a question for Yusra. Can you please tell us more about the maybe genetic background of the mice that you said aren't aging?
And here's a mic for you.
So basically, I'm working on genetic modified mice. So I knock out basically a gene that is responsible of the epigenetic changes. And when we knock out this gene, the mice doesn't age. So that's the principle. So it's a genetic modification. And the next step will be to deliver a drug that will target this exact same gene to have the same effect.
Great, thanks. All right, next question. Who's got a good one? Yes, in the back over there, Ross, if you can bring the mic.
Hello. Thank you all, first of all, for your speech. It's very nice, all of you. I have a question for Brian. Can you tell a little more about how different your approach is from immunotherapy, which currently exists in cancer treatment?
So I guess the closest immunotherapy to what I'm aiming towards is with dendritic cell immunotherapy. And there's a bunch of different types. And basically what happens in dendritic cell immunotherapy is you take a particular immune cell from the body called monocytes, you differentiate them into dendritic cells, which are these spies that I talked about. And then you take samples from the tumor and you basically give these samples from the tumor to the dendritic cells to train them, then put them back into the body. And the idea is that they have the information again to go to the soldiers to tell them what to do. But there's a lot of clinical trials on this and they're not all that successful. So again, what people are seeing a lot with different types of immunotherapy and different kinds of cancer treatments is that most of the times adding different types of treatments or having certain treatments with different types of modifications work better, again, depending on the cancer. So mine is basically targeting something within the lines of the same therapy, but then this time add in these energy boosting molecules that can basically help them produce more ATP. So basically, we were able to like show that like the spikes within like these tumor matrices, they produce less ATP, and this makes them like navigating the tumor environment like much more difficult, kind of. So yeah, we're basically trying to tackle that. Yeah.
Great, thanks. Yes. Well, we can give rounds of applause. Another question. Yes, we see right here. Toika's right behind you at the mic.
Thank you, everyone. Just a question for Mr. Ruster. So, yeah, I think I missed when you say like painting or coating like the cancer cell. What's the the material you coat? Is it like metal, noble metal coating for cells, or what's there?
Okay, basically it's a plastic underneath. So we just grow the cells, and then at the end we coat using some paraformaldehyde. So it's a solution, and then we just image them. So it's like normal well plate. You seed the cells, you treat with the cancer, and then you fix them, and you permeabilize them in order to let them dyes come in. So it's like normal well plate.
Thank you.
Thanks.
One more question for Meta.
Oh. Meta, here you go.
So when you said like injecting like CO2 under the ground, so is it like specific place like or desert or wherever like you inject the CO2, or how does that work? And does that affect too, like there is some like small animals, let's say like in the ground, so is that like kind of something dangerous too to
So there's a couple of factors to take into account when choosing a site. First of all, the carbon dioxide needs to stay in a supercritical condition. And for that, you need to inject it more than 80 kilometers below. And in terms of the site, there in the underground structures, there's different layers. And you need to find a site that has a very impermeable and basically a layer that won't let CO2 go back up. So there's certain criteria to take into account. And as for your second question, that's why we're doing some computational modeling with parametric studies. We need to look at the different injection rates and the temperatures and stuff to make sure there won't be any like human mini earthquakes or any tectonic movement or anything like that. And the main difference with our underground here in the Gulf is that CO2 will react, and when it reacts, it will turn into other rocks. And this rock might create stresses and affect the surroundings, and that's another thing that we need to take into account to prevent any cracks or anything that might cause the CO2 to escape.
Okay, thank you. You answered already. I want to catch up with the deep of. Thank you.
Great. We have 4 other speakers up here lonely waiting for a question. Yes, I see one.
Hi, guys. Thank you for the presentations. Amazing work, everyone. My question is for Ola. I wanted to understand when you create these knowledge graphs and when you say you're filling the missing links, how do you verify that those missing links are not mistakes? I imagine that you have to do it in a very high scale, not a small number. How do you verify those are not mistakes?
So first, so we have AI, it's intelligent. So usually mistakes happen when AI uses its intelligence to create information. So what we do is that we tell it, okay, we don't want you to create information. We want you to use your intelligence to read this huge network of facts and extract information from whatever I give you as facts. Now, these facts can be missing because sometimes it's not possible to represent everything that is true. So this is where we use a technique called link prediction to help the model predict these missing links. So we have a model that is trained on predicting missing links. So we remove a link, and then we train it on finding the ground truth. This is how it's trained. And then this way, we will be able to complete the graph with information based on true knowledge. And then we give this knowledge graph that is now complete to the AI and tell it, okay, reason over this knowledge and don't create from your own memory or your own knowledge.
Thank you.
Great, I think we have time for a few more questions. We got, soon. One right over there, Shadi.
Hi, thank you so much for the amazing speeches. Just a general non-sciencey question, anyone could answer this. What tip can you give to someone who's planning to join next year's GradSlam? I'm asking for a friend.
Great, Aman, why don't I give you?
Go for it.
I'll tell that friend.
Yes. Try it, do you have, Armeda? Yeah.
So one of the things that we all definitely agree on is that because we're so stuck in our research and we spent so many years on it, it took us a while to really reword it into layman's words and for a very broad audience. And it took us many trials to get to where we are today. So I would definitely go for the workshops. They really helped us to script what we put together today.
Yeah.
The advantage is that, now if my mom asks me, what do you do? I can answer. Before I wasn't able to answer.
Yes, and I know as somebody, I've worked with students in public speaking for a long time, but you never get worse at public speaking. You can just do it. It's like being an athlete. You can always just get better. The more you practice, the more that you do. That is something that we encourage anyone who's interested, who's in the audience today. Maybe this year, you're like, oh, I don't know if that's for me. Next year, you can be up here. You can be giving a great presentation like this. You can make your parents happy. All of those things. I see one. Yes.
Well, first of all, congratulations to all of you. I mean, I'm really impressed with the level of research that is being done here in the country, in the NYU Abu Dhabi, and your presentations were all amazing, fantastic. My question is for Jason. Your peel that sticks, you're now testing to see, to more like a camera to look at the intestine and see if there is a risk for cancer. Are you also thinking about having other use of this technique? Like, for example, have a peel of slow release of treatment or other things?
Sure. Oh, thanks. I'm agile today.
Thank you very much. I love that question because absolutely yes. So in our lab, we work on every single aspect of this pill. So the camera is probably the most basic function that we have. So another postdoc in my lab is working on microbiome sampling. So that's something the same device could do if you just swap out a couple of components. Someone else is working on drug delivery of targeting specific locations and different diseases. So that's something else. And then, sort of a big picture, ambitious thing that we're picturing is other sort of surgical and drug delivery capabilities. But I guess what I am working on is sort of just the prerequisite for such a pill to exist is that it has to be able to stay so that we have more control over this device. And then after that, we could do whatever we want, just swapping out a couple of components. So this is sort of like the step into the club. And then after that, you could dance however you want.
Great. I think we're almost ready for the scores. So I'm going to ask one more kind of quick question, to all of you. It's just, what do you think is the most important thing you learned, in kind of preparing for this type of presentation? Whether that was about how to communicate about your research, about presenting. What is it that you can share? And I'll have each one of you just say something very, very quickly. So I'll start. Or Yusuf, I've got you.
I think the most important is to focus on the why, because when you have general audience, they just want to know why we're doing our research. So I think that's the most important part of our speech is to just like see what we are doing and actually what will be the impact out there, because sometimes we are in the lab and we are like forgetting about why we are doing this, and this is a very good way to just stop and say, okay, why am I doing this? And then that's how we get the speech out.
Great. Maitha, are you willing to
If
share?
I can add to Yusra, I think the whole experience is very different. I mean, we as a researchers or scientists, we spend a lot of time in the lab, so we don't communicate much with, public people. So even, I mean, using the simple language to convey our research, it's not easy. Spending, a lot of time in the lab, within the scientific community, the terminology that we use is different. Everything is different. I mean, this whole experience, competing in this GradSlam is just, I would say it's a life-changing for me. My presentation skill wouldn't be the same after this.
Great. Write that on the notes, whoever's, use that for the annual report right there.
What my colleagues here said, and I think it's a nice opportunity to step out of your comfort zone, try something new. You got nothing to lose, and like you said, improve your public speaking skills.
Yeah, I think they said it all. But mainly it's about reminding ourselves what are we doing and the impact of what we're doing, and this is really very motivating.
Just one thing, research is multidisciplinary, and the GradSlam experience was like a tiny experience that mimicking that. So I believe many brains are better than one brain, and that was there during the workshops. We were trying to help each other to shape our ideas to get to here.
Great. Brian, anything to add?
I think mostly the same things they said, right? I have the same presentation in the scientific forms I would present to experts, and if I presented that here, everyone would be bored, and at the end of the presentation, you will be okay, so yeah, what do I do with this? And sometimes even we ask ourselves the same question, because some of the things you're doing are most of the times very minute part of the bigger picture, that this helps you appreciate that more.
Mm-hmm. Yeah, Rustin, do you have any, or Jace, either of you have anything else?
Yeah, basically all cover, but maybe I could add the benefit from joining this GradSlam is for potential collaboration. So basically you meet with people different backgrounds. So because of this, I just met with the Ola and I spoke about AI because I utilize AI, machine learning, to speed up, to select, to pick up which one drug that change the painting. So yeah, that's
great.
What I think.
Great.
I guess I'll echo what everyone said here. And I guess if there's one thing I can add, I really like your example about, just this being similar to a sport. I think there's always room to grow, and there's always, a chance to practice. I would always like to take that, and it's sort of a lifelong journey of learning and growing. But that's it. Thank you.
All right, well, let's give one final round of applause for everyone. Feel free, take your seats. I have some very important envelopes in my hand that tell the winners, but before we announce our 3 winners tonight, we have a lot of people to thank. First, we want to thank our judges who came here, put in the hard work, made the hard choices to see who's going to be the winners tonight. We want to thank our Office of External Relations, who helps us promote this event and to make it look as beautiful as it is tonight as well. Our Audiovisual Services team, who are doing a fantastic job of coordinating a lot of different moving parts all at once right now. We have our workshop facilitators, Linda Mubarak, Aliyah Soliman, who helped prepare our students and postdocs for the event tonight. We also want to thank our postdocs and our PhD students who took part in the semifinals. Again, there were 30 students and postdocs who participated in this event. You got to see the finalists, but there's a lot of other students who helped participate and add to the workshops and these groups. And of course, we do want to really thank our sponsor for this year, for 2025, PharMag. This has just been a great collaboration. We really thank you in just encouraging our students to innovate and to do great things. And so we thank you very much for being a part of this. And last, he did not write his name on the board here, but with the GBPO office, everyone has to come together for this. I got to be the person up here who talks to everyone, but this event would not exist without Ross Fleming. Give him a round of applause. thank Ross and Ken and Aisha and Toika, who all helped from our office to make sure that we all got to see these presentations tonight. And so you're like, stop talking, tell us who won. With the People's Choice Award, congratulations, Iman Morjan. Yes, and I believe if you'd like to come up, we're going to take a picture. I believe we can hand them the award. Come. Yes, we go right on stage here in the middle. Yes, congrats. Aman, you can remain on the stage over there. And then our runner-up. I feel tense. Congratulations, Restaurant Lubis. Congratulations, second place. Okay. All right, and can I get a drum roll from there? We've got one. Our 2025 GradSlam winner. Congratulations to Yusra Ajnu. So we have this to present. And if you don't mind, here you go. Very fancy. Oh, and one last, I've been waiting to do this my whole life. Here we go, picture with the grand prize. Oh, I get to get in here too. Here, oh, I'll come in on the other side. That way, yeah. Here we go, I'll hold.